Hello students, welcome to our channel JEE Physics. So today we're going to discuss JEE main question from most interesting chapter work power energy April attempt. So we're going to discuss all the question in detail, and to explore more regarding physics, join in our Instagram page and WhatsApp channel. Links are in the description. So let us discuss the questions. See the first question. An object of mass 100 gram experiences a time dependent force. So they have given the value for force. They are asking to find the power. So for that we can take the formula power is equal to F dot V. So we know the data for the force. We have to find the velocity. So to find velocity we can find acceleration. So for that I am going to take Newton's law, that is F is equal to ma, that is A is equal to F by m. So we will substitute for force, that is 2t I cap plus 3t square j cap by mass is 1000 grams. So we can substitute as 1 kg. So that is 1. So we'll get the acceleration as A is equal to 2t I cap plus 3t square j cap. Okay. So if you're integrating acceleration with respect to time, we will get velocity. So I'm going to integrate acceleration with respect to time. So V is equal to integrating 2t I cap plus 3t square j cap with respect to dt. Okay, so we will get it as V is equal to 2t square by 2 I cap plus 3t cube by 3 j cap. Okay, so 3 will get cancelled, here 2 will get cancelled. So we got the velocity as V is equal to t square I cap plus t cube j cap. Okay, so already we know force and we got the velocity. Now we can calculate the power. So power formula, power is equal to F dot V. So force equation 2t I cap plus 3t square j cap dot velocity t square I cap plus t cube j cap. Okay, so now we'll take the dot product. So 2t into t square, we'll get it as 2t cube plus 3t square into t cube, that we will get it as 3t power 5. So this is power. We'll check the option. Option 4 is the right answer. Second question, an object with mass 500 gram moves along x-axis with the speed. They have given the equation for speed. They are asking us to find the force. So first we'll take the equation V is equal to x. In the place of root x, I'm going to substitute x power 1 by 2. Okay. So if we're differentiating velocity with respect to time, we will get the acceleration. But here we have position. So we can differentiate velocity only with respect to the position. So dv by dx is equal to 4 into 1 by 2 x power minus 1 by 2. Okay, so this is 1 and 2. Okay, so we need dv by dt. So what I'm going to do is, so I'm going to multiply and divide by dt, and I'm going to interchange this dt and dx. Okay, so listen, so dv by dt, we can take dt to the opposite side, that is equal to 2x power minus 1 by 2. I'm going to take this dx to the opposite side. So dx by dt. Is it okay? So now we can see dv by dt is acceleration A, that is equal to 2 into x power 1 by 2. dx by dt is velocity. So we can write it as v. Okay. So A is equal to 2x power minus 1 by 2. In the place of velocity, we can take this equation, that is 4x power 1 by 2. Okay, so x power minus 1 by 2 plus 1 by 2, it will get cancelled. So A is equal to 2 fours are 8 meter per second square. So they are asking us to find the force. So we can take the formula F is equal to ma. Mass is 500 gram, which is 0.5 kg, and acceleration is 8. So this is 4 Newton. Okay, so we'll check the option. Option 4 is the right answer. Next theory question, which of the following forces can't be expressed in the terms of potential energy? So it's a direct theory question. Frictional force. So friction force can't be expressed in the terms of potential energy because it's a non-conservative force. So non-conservative forces can't be expressed in the terms of potential energy. Okay, so friction force is the right answer. So other three, that Coulomb force, gravitation force, restoring force, these are conservative force. It can be expressed in the form of potential energy. Next question, a block of mass 1 kg moving along x-axis with the speed 10 meter per second enters a rough region ranging from x is equal to 0.1 to 1.9. The retarding force acting on the block F is equal to minus kx. They have given the value for x also. They are asking us to find the final speed of the block. So for that we can take the equation, that is work is equal to change in kinetic energy, and for work we have one more formula, that is integrating force with respect to the position. Okay, so we will explain this equation. So change in kinetic energy means final minus initial. Final kinetic energy half mv square, initial kinetic energy is half mu square, that is equal to integrating in the place of force minus kx and dx. Okay, so now we will take the common terms out, that is half m is common, v square minus u square is equal to integrating minus in the place of k we can substitute 10x into dx. We have the limit also, lower limit is 0.1, upper limit is 1.9. Okay, so now we can substitute the value. So 1 by 2, mass is 1, v square minus u is 10, so 10 square, that is 100, that is equal to, if you are integrating, minus 10 x square by 2. So the limit is 0.1 to 1.9. We can take the common term out. So this is 1 and this is minus 5. We'll take the minus 5 outside. So 1 by 2 v square minus 100 is equal to minus 5. We'll take it as a common. Balance upper limit minus lower limit, that is 1.9 square minus 0.1 square. Is it okay? So now we'll calculate this one. So v square minus 100 is equal to, we can take 2 to the opposite side. So minus 10, 1.9 square, that is 3.61 minus 0.01. Okay. So v square minus 100 is equal to minus 10 and this will be 3.6. So next one we will multiply this. So minus 36 and we will take minus 100 to the opposite side. So plus 100, that is v square. So v square is equal to plus 64. We will take this square to the opposite side. So root 64 is 8 meter per second. So we'll check the option. Option 4 is the right answer. Next one, it's a most important question. A block of mass 25 kg is pulled along the horizontal surface by a force of angle 45 degree with the horizontal. The frictional coefficient between block and the surface is 0.25. The block travels with the uniform velocity. The work done by the applied force during the displacement 5 meter. Okay. So for that, first we'll take the diagram. Let us consider this is the surface. And you have a block of mass 25 kg. So first of all, we'll write the force. Okay, so first gravitation force will act on this object. Okay, so mass is 25. So the gravitation force will be always downward. So that is mg. So I can write it as 25g. And perpendicular to the surface, there will be a normal force acting on it. They have applied the force 45 degree with respect to the horizontal. So this is the applied force F, which makes an angle theta, which is 45 degree. So this we can write it as F cos 45 degree, and perpendicular to this we can write it as F sin 45 degree. So there is a friction force acting on the surface. So friction force always opposes the motion. So it will be opposite to the applied force and parallel to the surface. So this is the friction force. Okay, so now we can write the equation. So first of all, here the object will move horizontally so that the vertical forces will be equal. So we can take the vertical forces. So upward force, that is normal, plus F sin 45 degree. So downward force, that is equal to mg, which is 25g. So now substitute the value. Normal force plus F in the place of sin 45, 1 by root 2, that is equal to, in the place of g we can substitute 10, so which is 250. We can take this to the opposite side. So normal is equal to 250 minus F by root 2. Okay, so now we can see the question. The object is moving with the uniform velocity. If it's uniform velocity means velocity is constant. So acceleration is 0. There is no external acceleration. That means there is no external force. So the net force goes to 0. So that the applied force will be equal to the friction force because you have no net force. Okay, so we can equate the equation, that is F cos 45 degree is equal to the friction force. So F cos 45 is 1 by root 2, that is equal to friction. Friction is coefficient of friction into normal. So already we know the normal. We can substitute in the relation, that is F by root 2 is equal to coefficient of friction is 0.25. So 0.25 I am going to substitute as 1 by 4 and normal is 250 minus F by root 2. Okay, so now we will do the calculation. So F by root 2 is equal to 250 by 4 minus F by 4 root 2. So we can take this to the opposite side. So F by root 2 will become common, balance 1. So it's minus 1 by 4, opposite side plus 1 by 4, that is equal to 250 by 4. So if you cancel this means you will get it as 250 by 4. Okay. So if you cross multiply F by root 2 into 5 by 4 is equal to 250 by 4. So we can cancel 4 on both the sides and this is 1 and it's 50. So we can take root 2 to the opposite side. So we can write it as F is equal to 50 root 2. So now we have to find work done by the applied force during the displacement 5 meter. Okay. So for that we can take the work formula. Work is equal to F dot S. But here the applied force is F cos 45. That is because the object is moving horizontally. So the horizontal force is F cos 45. So F cos 45 into displacement S. Okay. So F cos 45 is 1 by root 2. So displacement they have given it as 5. So we know the F value, we can substitute in the equation. So F is 50 root 2 into 1 by root 2 into 5. So root 2 will get cancelled. So 50 into 5, that is 250 joule. Okay. So in this question, I took G as 10. So I got the answer as 250. Suppose if you are taking G as 9.8, we'll get the correct answer, which is 245. So here I took an approximate value for G, that is 10. So I got the answer which is close to the right answer. So anyway, option D is the right answer. Okay students, we have reached end of the session. So if you have any doubts or queries, please do comment in the comment box. And to watch more video like this, don't forget to subscribe our channel. Thank you students.